Hello, all. Thanks for joining us today. Jason and I held a podcast about Bitcoin, both the foundations and cryptographic strengths, but also then got into the risk of quantum computing, protecting Bitcoin, and even the potential need for a new version of Bitcoin, while we also dive into ideas surrounding geopolitical dynamics and the risks from China. So please enjoy the podcast, and we will see you on the other side. This podcast was recorded on January 10th, 2025.
Okay, before we get to a complex future and the existential threat of quantum computing on every Bitcoin that's in circulation, let's start right at the essence of Bitcoin and this revolutionary idea of a decentralized currency. It's a system that by design operates completely free of intermediaries like banks or governments. And what ensures this freedom is the blockchain, a transparent, distributed ledger that records every transaction ever made. Ophir, break this down for us. How does the tech and mathematics behind this achieve trust without centralized control?
So, at its core, Bitcoin's cryptographic backbone relies on two key concepts: digital signatures and public-private key cryptography. When you make a Bitcoin transaction, you're essentially signing off using your private key, which is like a secret password. Only the corresponding public key can verify that signature. What makes this secure is the underlying math. It's computationally infeasible to derive the private key from the public key, and because everything is recorded publicly on the blockchain, anyone can verify the validity of that transaction.
Right, and that ensures trust, even in a system where none of the users have to trust each other. It's almost like handing someone a sealed envelope that only they can open, but the envelope itself is on display for the whole world to see. And then there's proof of work. I think this is where Bitcoin really flexes its muscles as a decentralized powerhouse.
Exactly. Proof of work is an ingenious mechanism. Actually, all of that introductory white paper on Bitcoin was ingenious. It's essentially a competition where miners race to solve a computationally complex math problem. The winner gets to add a new block of transactions to the chain and is rewarded with Bitcoin. But here's the catch. Every calculation required to solve this problem takes enormous computational power and energy. That's intentional. It's what makes the system resistant to tampering. To alter even one transaction in the blockchain, you'd need to redo the proof of work for that and every subsequent block, which is practically impossible.
Yeah, and let's not forget about the halving schedule, where the rewards for mining are cut in half every 4 years or so. It's Bitcoin's way of mimicking finite resources like gold. But, not everything about Bitcoin is smooth sailing, though. There's the transaction bottleneck, the fees. Do you want to touch on that real quick?
Sure. Bitcoin's design uses a block weight limit equivalent to around 2 megabytes of data on average. It was originally about 1 megabyte, which, realistically, means it can still process roughly 7 transactions per second. Compare that to Visa, which can handle over 20,000. As Bitcoin's popularity has grown, this limitation creates bottlenecks, leading to higher fees and longer processing times when the network gets congested. There's been a lot of debate on how to address these scalability challenges. Some focus on increasing block size, while others advocate for off-chain solutions like the Lightning Network.
Exactly. Those scalability debates have really divided the crypto community at times. But it's all part of Bitcoin's evolution, right? The tech needs to adapt to meet its growing demands, which in a way echoes why decentralized systems are so resilient. But hold on, as academic as this sounds so far, this foundation of cryptography we've been gushing about, it could be at serious risk. And that brings us to quantum computing.
Yes. Suddenly headline-worthy? So, quantum computing represents what some might call the ultimate disruptor for systems like Bitcoin or anything that lives and breathes on current-day cryptography. To understand why this new technology is being discussed as a potential threat, let's first break down what makes quantum computing so different. Unlike traditional computers that use bits, binary digits that are either a 0 or a 1, quantum computers operate using qubits. Qubits leverage quantum phenomena like superposition, meaning they can represent 0, 1, or even both at the same time. Pair that with entanglement, where qubits are interlinked regardless of distance, and the result is a level of computational power that can tackle specific problems far beyond what classical computers can achieve.
Yeah, quantum computing is like, I don't know, it's like unlocking an entirely new dimension of thinking. But how does this leap threaten Bitcoin specifically? Can we make the risks tangible here?
Absolutely. At the heart of Bitcoin, security lies the elliptic curve digital signature algorithm, or ECDSA. This algorithm keeps transactions secure by ensuring only the private key holder can authorize transfers. Now, here's the crux of the issue. Quantum computers running Shor's algorithm can theoretically crack ECDSA. Specifically, it enables deriving private keys from public keys, which means someone could forge a signature and steal Bitcoin. Based on current estimates, a sufficiently powerful quantum computer, one needing about 4,000 error-free qubits, could break this cryptography.
So we're talking about breaking into the locks that protect Bitcoin wallets. That's profoundly unnerving. And there's more, right? This hashing problem, which Bitcoin depends on, that's also not safe, is it?
That's correct. Bitcoin miners solve cryptographic puzzles called hashes to validate transactions in a process called proof of work. Grover's algorithm, another quantum algorithm, optimizes the brute force search required to attack these hashes. It doesn't make the system completely vulnerable, but reduces the computational time significantly, so it's a security concern in the long run. Combine that with Shor's and, well, it's a 1-2 punch.
And there's this sneaky little concept that's been floating around lately. Harvest now, decrypt later. Basically, wallets that are still encrypted are not safe if bad actors decide to archive their data today, right?
Precisely. If someone intercepts transaction data now, even without the computational power to decrypt it using classical systems, they can store it and wait. Once quantum computing reaches maturity, they could go back and decrypt that archived data, essentially compromising transactions made long before. This risk is particularly acute for the several million bitcoins, worth billions, stored in public key revealing addresses, or reused addresses vulnerable to quantum attacks.
That's staggering, and I mean, some of these are probably long abandoned wallets, but still, that's a terrifying number. Anyone holding Bitcoin right now needs to take this threat seriously. It's like knowing your password is going to be hacked in the next X years, but not knowing exactly when.
Correct. And it underscores the importance of transitioning Bitcoin's infrastructure to quantum-resistant cryptography sooner rather than later. But honestly, this isn't a simple fix. There are a lot of challenges involved, from community consensus to implementation logistics.
I think this is a good time to pause for a second for a quick but deeper dive into this idea that several million coins are vulnerable, but there are about 20 million coins outstanding. What is the difference between coins stored in public key revealing addresses and those that are not? And are the others coins therefore safe from a quantum computing driven attack?
My best effort at a short answer is this. Right now, Bitcoin's ECDSA signatures are safe from classical computers if only the hashed version of the public key is known. But if the full public key is ever revealed on-chain, like in early Satoshi-era pay-to-public key outputs or reused addresses, those coins could be at higher risk once large-scale quantum computers arrive. Quantum algorithms like Shor's could in theory extract the private key from a revealed public key. That's why millions of Bitcoin locked up in these older or reused addresses are considered more vulnerable to a future quantum threat.
Does that mean the other 15 million or so other Bitcoin are safe?
Not exactly. I would say that safer doesn't mean invulnerable. It just means quantum attacks are far less straightforward if the actual public key is never exposed. But, taking a step back, there is risk throughout for all Bitcoins.
Right. And I think that's a perfect point for the next leg of this conversation. Let's unpack what it would actually take to transition Bitcoin to post-quantum cryptography. Soft forks, hard forks, community debate, you name it. As we were saying, transitioning Bitcoin to quantum-resistant cryptography isn't just flipping a switch. It's a monumental task. At the core of this are two pathways: soft forks and hard forks. A soft fork is the more palatable option. It's backward compatible, meaning non-upgraded nodes can still participate. But here's the thing. It requires at least 90% minor consensus to enforce new rules, which is anything but easy to achieve.
90%. Wow. That's a really high bar. And correct me if I'm wrong, a hard fork's even tougher, right? Because it's permanent. You risk splitting the network if not everyone agrees?
Exactly. A hard fork introduces changes that are fundamentally incompatible with existing protocols. It would require near unanimous cooperation across all nodes, and even then, there's no guarantee. A split could lead to two blockchains running concurrently, dividing both assets and community trust.
That sounds like chaos waiting to happen. And let's not forget, the geopolitical chessboard complicates this even more. I mean, with maybe 20% to 30% of Bitcoin nodes already concentrated in China, what's to stop them from playing spoiler? They could just refuse to participate in forks, delaying the transition, and leaving the entire system exposed.
That's a real concern. Geopolitical dynamics absolutely factor in here. If a significant portion of nodes resist change, then implementing quantum-resistant measures becomes infinitely harder. And it's not just passive resistance. A coordinated actor could deploy new nodes en masse, gaining majority influence over decisions like forks or even blocking proposed upgrades.
And the incentives for doing so are pretty clear, right? Like, imagine if Bitcoin becomes part of the US National Reserve. China, or anyone really, could undermine trust in the system just to destabilize the competition. They wouldn't even need brute force to derail progress.
Absolutely. That's the double-edged sword of decentralization. While no single entity controls Bitcoin, the network's distributed nature leaves it vulnerable to collective manipulation. So, to counteract this, we need to focus on decentralizing node distribution even further, getting more countries, institutions, and individuals to participate.
Decentralization? Yeah, that's the key here. But it's still just one solution. What about awareness? I feel like the average Bitcoin holder, or even small-time miners, they're kind of oblivious to this quantum stuff. I mean, it's suddenly headline material, but it wasn't too long ago.
You're right. Community education needs to be a priority. You know, the risks must be communicated clearly, and we need buy-in from all levels of the ecosystem. Holders, miners, developers, and policymakers. Without broad awareness and alignment, any meaningful transition to quantum-resistant cryptography will stall.
And let's talk urgency. Institutions like NIST are already working on quantum-resistant algorithms. We're talking lattice-based cryptography, multivariate techniques, a whole new generation of encryption. But how realistic is it to implement these upgrades in time?
That's the multi-billion-dollar question. While NIST's work provides a solid foundation, the implementation in Bitcoin or any blockchain requires extensive testing and massive logistical coordination. It's not just about swapping algorithms. It affects everything from wallet compatibility to transaction validation. And even then, it's a race against quantum advancements.
So basically, best case scenario, this is going to be messy, but we have to act now because once quantum hits critical mass, it'll already be too late. There isn't a plan B here, right?
There isn't. And I think that's where decentralized efforts combined with institutional support become paramount. Multiple stakeholders need to converge on a unified plan, whether it's through forks, new protocols, or entirely rethinking Bitcoin's cryptographic framework.
Completely rethinking. It almost feels like tearing down the house to rebuild it with stronger foundations. And on that rather daunting note, I think we're ready to dive deeper into Bitcoin's current cryptographic limitations. Jason, you up for deconstructing ECDSA and hashing more next?
Right, let's break this down further. When we look at Bitcoin's existing architecture and its cryptographic underpinnings, the key question becomes, what if the complexities of upgrading prove insurmountable? That's when the notion of building an entirely new blockchain designed from the ground up to be quantum resistant starts to enter the conversation. It's a drastic move, but given the stakes, it might just make the most sense.
A new blockchain, you're saying, effectively Bitcoin 2.0. I mean, that has massive implications, Jason. This is the godfather of cryptocurrencies we're talking about. Would the community even accept that?
That's the big question. On one hand, starting fresh allows developers to integrate the latest post-quantum cryptographic techniques lattice-based signatures, for example, and resolve long-standing issues like scalability and energy efficiency. But on the other, we're talking about leaving behind over a decade of brand equity, liquidity, and trust that Bitcoin has built. The risk of fragmenting the community is enormous.
Enormous might be an understatement. Let's face it. Bitcoin's reputation is part of its value. If you fracture that, if liquidity dries up, what happens to institutional adoption? What about the miners, the exchanges? It's like starting a tech company in an already saturated market, except instead of competitors, you're competing against your own history.
Exactly. That's why a successful transition, whether it's via an upgrade or a new blockchain, requires coordinated effort across the entire ecosystem. Developers, miners, investors, even policymakers. It's the only way to preserve trust while adapting to an entirely new cryptographic standard.
And trust is the key word here. Without it, no amount of technical brilliance matters. What about governance, though? What kind of model do you think would help handle these transitions seamlessly?
We'd likely need a much more adaptable governance system, something that accelerates decision-making without sidelining smaller stakeholders. A robust model would include public input channels, but also a clear escalation path for critical upgrades. It can't just be about majority voting. It has to align incentives across the board.
And that means transparency, right? It's not enough to make these decisions behind closed doors. You need buy-in. You need developers, governments, institutions, and retail holders all to align. Easier said than done. But here's the thing. If Bitcoin was able to rally a global, decentralized community in 2009 to create an entirely new system of trust, why can't it do it again?
That's an inspiring perspective, Ophir. And you're right. Bitcoin's origin was a testament to collaboration against the odds. Today, the stakes might be even higher, but so is our collective capacity to solve complex problems. We just need to act before quantum computers mature enough to turn these theoretical risks into real ones.
Well, that brings us full circle, doesn't it? From Bitcoin's cryptographic brilliance to what could be its Achilles heel, and finally the possibility of a resilient new chapter. Jason, any final thoughts?
Just that we're at an inflection point, a moment where proactive change is not optional but necessary. But also, I think it's a chance to innovate beyond what we thought was possible to secure not just Bitcoin, but the very concept of decentralized finance for future generations.
And on that note, here's the bottom line, folks. The future of Bitcoin isn't written yet. But one thing's clear, it's up to all of us, the global community, to decide what happens next. Thanks for joining us on this journey. Until next time, stay curious, stay informed, and stay engaged, and thank you for joining us on CML Podcast.